Find the value of cos inverse of cos 13 pi by 6. We know that cos inverse of cos x is equal to x. So here, replacing x by 13 pi by 6, we can expect an answer to be 13 pi by 6. But 13 pi by 6 doesn't belong to 0 to pi, which is the principal branch of cos inverse x. So we have to simplify 13 pi by 6. We know that 13 pi by 6 can be written as 2 pi plus pi by 6. We can eliminate 2 pi and will be left with pi by 6, and pi by 6 belongs to 0 to pi. So cos inverse cos 13 pi by 6 is equal to pi by 6. Find the value of tan inverse of tan 7 pi by 6. We know that tan inverse of tan x is equal to x. So here tan inverse tan 7 pi by 6 can be written as 7 pi by 6. But we know that 7 pi by 6 doesn't belong to minus pi by 2 to pi by 2, which is the principal branch of tan inverse x. So we have to transform 7 pi by 6 to this range. Now we know that 7 pi by 6 can be written as pi plus pi by 6. Tan has a period of pi, so we can ignore the pi and this becomes tan pi by 6. And pi by 6 belongs to minus pi by 2 to pi by 2. Therefore, tan inverse tan 7 pi by 6 is equal to pi by 6. Prove that 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. On the left hand side we have 3 by 5, which forms a Pythagorean triplet, 3 square plus 4 square equal to 5 square. Also the left hand side is in sine and the right hand side is in tan. So we need a way to transform sine to tan. Now let's assume sine inverse 3 by 5 is equal to theta, or sine theta is equal to 3 by 5. Then we can find out cos theta using under root of 1 minus sine square theta, and tan theta through sine theta by cos theta. We can find these cos theta and tan theta directly using the 3 square plus 4 square equal to 5 square. Now we can calculate tan 2 theta, which is equal to 24 by 7. We can take inverse of this, so we get tan inverse of 24 by 7 is equal to 2 theta. We can substitute theta from our assumption, so we get the result 2 sin inverse 3 by 5. Hence this 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. Prove that sin inverse 8 by 17 plus sin inverse 3 by 5 is equal to tan inverse 77 by 36. We see here that there are two Pythagorean triplets used on the left hand side, 8 by 17 and 3 by 5. Also the left hand side is summation of two angles and the right hand side is in tan. So let's start with assuming sin inverse 8 by 17 is equal to theta 1 and sin inverse 3 by 5 is equal to theta 2. Then we can find out the other angles, that is cos theta 1 tan theta 1 and cos theta 2 tan theta 2. So the left hand side is theta 1 plus theta 2. So for the right hand side we start by calculating tan theta 1 plus theta 2. We already have values of tan theta 1 and tan theta 2. We can substitute it to get 77 by 36. Now we can take tan inverse on both the sides, giving us tan inverse 77 by 36 is equal to theta 1 plus theta 2. We can substitute theta 1 and theta 2 from our assumption to get tan inverse 77 by 36 is equal to sin inverse of 8 by 17 plus sin inverse of 3 by 5. Prove that cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. On the left hand side we have two terms in addition and the right hand side is having cos, which means we can apply here cos of addition of angle formula. Also note that the values 4 by 5 and 12 by 13 form a Pythagorean triplet. So let's start with assuming that cos inverse 4 by 5 is equal to theta 1 and cos inverse 12 by 13 is equal to theta 2. From this we can find the sin theta 1 and sin theta 2. Now we can substitute these values in cos of theta 1 plus theta 2 formula and get 33 by 65. If we take cos inverse on both sides, we get theta 1 plus theta 2 is equal to cos inverse 33 by 65. We know the value of theta 1 and theta 2 from our assumption. On substitution, we get cos inverse 4 by 5 plus cos inverse 12 by 13. Hence, cos inverse 33 by 65 is equal to cos inverse 4 by 5 plus cos inverse of 12 by 13. Prove that cos inverse 12 by 13 plus sin inverse 3 by 5 is equal to sin inverse of 56 by 65. On the left hand side we have two terms in addition and the right hand side is in terms of sine. So we can apply here sine of addition of angle formula. Also note that 12 by 13 and 3 by 5 form the Pythagorean triplet. We'll start with our assumption that cos inverse 12 by 13 is equal to theta 1 and sin inverse 3 by 5 is equal to theta 2. Now we can find out sine of theta 1 and cos of theta 2. Now sin theta 1 plus theta 2 is equal to sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. Substituting the values, we get 56 by 65. If we take sine inverse on both sides, we get theta 1 plus theta 2 is equal to sine inverse of 56 by 65. We know theta 1 and theta 2 from our assumption, hence we get sin inverse 56 by 65 is equal to cos inverse 12 by 13 plus sin inverse 3 by 5. Prove that tan inverse 63 by 16 is equal to sin inverse 5 by 13 plus cos inverse 3 by 5. The right hand side is a summation of angle and the left hand side is tan, so we can think about applying tan of summation of angle here. Also note that 5 by 13 and 3 by 5 form Pythagorean triplet. So let's start by assuming sin inverse 5 by 13 is equal to theta 1 and cos inverse 3 by 5 is equal to theta 2. From this we can find out cos theta 1 and tan theta 1 and sin theta 2 and tan theta 2. Now we can apply the tan theta 1 plus theta 2 formula. We have already got tan theta 1 theta 2. Substituting it, we get 63 by 16. Taking tan inverse on both sides, we get theta 1 plus theta 2 is equal to tan inverse of 63 by 16. Theta 1 and theta 2 we can substitute from our assumption to get tan inverse 63 by 16 is equal to sin inverse 5 by 13 plus cos inverse 3 by 5. Prove that tan inverse root x is equal to half of cos inverse 1 minus x by 1 plus x, where x belongs to 0 to 1. We see that both left hand side and right hand side are very well defined over the domain 0 to 1. So we'll start by assuming root x is equal to tan theta, which implies that tan inverse of root x is equal to theta and x is equal to tan square theta. Substituting x is equal to tan square theta in the right hand side, we get half of cos inverse 1 minus tan square theta by 1 plus tan square theta. Now we already know that 1 minus tan square theta by 1 plus tan square theta can be written as cos 2 theta. Substituting this and simplifying it, we get equal to theta, which is same as equal to tan inverse root x. Prove that cot inverse of under root 1 plus sin x plus under root of 1 minus sin x divided by under root of 1 plus sin x minus under root of 1 minus sin x is equal to x by 2, where x belongs to 0 to pi by 4. X belonging to 0 to pi by 4 implies that x by 2 belongs to 0 to pi by 8, and in this domain cos x by 2 is greater than sin x by 2. We know that sin x can be written as 2 sin x by 2 and cos x by 2, and 1 can be written as sin square x by 2 plus cos square x by 2. Substituting 1 and sin x, we can find 1 plus sin x. This becomes a perfect square. Now we can take the square root on both sides to get square root of 1 plus sin x is equal to sin x by 2 plus cos x by 2. Similarly, we can find 1 minus sin x, but we need to note that cos x by 2 is greater than sin x by 2 in the given domain. So here under root of 1 minus sin x will be equal to cos x by 2 minus sin of x by 2. Substituting under root of 1 plus sin x and under root of 1 minus sin x on the left hand side, we get 4 terms in the numerator and 4 terms in the denominator. Here in the numerator sin x by 2 gets cancelled, and in the denominator cos x by 2 gets cancelled, and we are left with cot inverse of 2 cos x by 2 by 2 sin x by 2. Again 2 gets cancelled, and cos by sin can be written as cot x by 2. Now cot inverse of cot x by 2 is equal to x by 2. The left hand side is a tan inverse function having two under root terms, 1 plus x and 1 minus x, and the right hand side is pi by 4 minus half of cos inverse x. We are also given that x belongs to minus 1 by root 2 to 1. So we start here by assuming x is equal to cos 2 theta. Now we know that cos 3 pi by 4 is equal to minus 1 by root 2 and cos 0 is equal to 1. So the domain of x, which is minus 1 by root 2 to 1, can be written in terms of 2 theta as 0 less than equal to 2 theta less than equal to 3 pi by 4. or 0 less than equal to theta less than equal to 3 pi by 8. Now from the assumption x equal to cos theta, we can find 1 plus x, which will be equal to 1 plus cos 2 theta, and this is equal to 2 cos square theta. Same way, 1 minus x is equal to 1 minus cos 2 theta, which is equal to 2 sin square theta. Substituting 1 plus x and 1 minus x on the left hand side, we get tan inverse of root 2 cos theta minus root 2 sin theta divided by root 2 cos theta plus root 2 sin theta. We can take root 2 common in numerator and denominator, and then we can cancel it out, giving us tan inverse of cos theta minus sin theta divided by cos theta plus sin theta. We can divide both numerator and denominator by cos theta, giving us 1 minus tan theta in the numerator and 1 plus tan theta in the denominator. So substituting tan pi by 4 equal to 1, we can change it to tan of a minus b format, where a is equal to pi by 4 and b is equal to theta. Replacing this by tan a minus b formula and further simplifying, we get pi by 4 minus theta. Now note here that theta belongs to 0 to 3 pi by 8. So this pi by 4 minus theta belongs to minus pi by 2 to pi by 2, which is the principal branch of tan inverse. From the assumption x equal to cos 2 theta, we can substitute theta is equal to half of cos inverse x, giving us the answer pi by 4 minus half of cos inverse x. Solve 2 tan inverse cos x is equal to tan inverse of 2 cosec x. We'll start by assuming that both left hand side and right hand side is equal to theta. Solving individually for both the sides, we get that 2 tan inverse cos x is equal to theta, or tan inverse cos x is equal to theta by 2. Applying tan on both sides, we get cos x is equal to tan theta by 2. Now we can use tan 2a formula, where a is equal to theta by 2, to get tan theta is equal to 2 cos x by 1 minus cos square x, which is equal to 2 cos x by sin square x. Solving for the right hand side, we get tan inverse 2 cosec x is equal to theta. Applying tan on both sides, we get 2 cosec x is equal to tan theta. Now equating both equation 1 and 2, we get 2 cos x by sin square x is equal to 2 cosec x. Simplifying this, we get cos x is equal to sin x. Now this is possible only when x is equal to pi by 4 in the first quadrant, or x is equal to 5 by 4, which is in third quadrant. So the general solution is x is equal to n pi plus pi by 4, where n belongs to z. Solve tan inverse 1 minus x by 1 plus x is equal to half of tan inverse x, where x is greater than 0. So let tan theta is equal to x, or theta is equal to tan inverse x. Substituting this on the left hand side and also applying tan pi by 4 is equal to 1, we get tan inverse of tan pi by 4 minus tan theta by 1 plus tan pi by 4 tan theta. This is of the format tan a minus b, where a is equal to pi by 4 and b is equal to theta. Applying it and simplifying, we get left hand side is equal to pi by 4 minus theta. Similarly, the right hand side, half tan inverse x is equal to half of theta. Equating both equation 1 and 2, we get pi by 4 minus theta is equal to half theta. Simplifying this, we get theta is equal to pi by 6. Now from our assumption, x is equal to tan theta, so x is equal to tan pi by 6 or 1 by 3. Simplify in terms of x, sine of tan inverse x, where absolute value of x is less than 1. Let tan theta is equal to x, which implies that tan inverse of x is equal to theta. Applying sine on both sides, we get sine of tan inverse of x, which is the left hand side, is equal to sine theta. Now sine theta can be written as product of tan theta and cos theta, where cos theta can be further written as 1 by sec theta. From sec square theta equal to 1 plus tan square theta, we can replace sec theta as under root of 1 plus tan square theta. Now we can substitute tan theta is equal to x to get the answer x divided by under root of 1 plus x square. Solve sin inverse 1 minus x minus 2 sine inverse x is equal to pi by 2 and find the correct option. We'll start by evaluating the left hand side at all values, that is at x equal to 0, half and 1. At x is equal to 0, our left hand side becomes sine inverse of 1, which is equal to pi by 2. At x equal to 1, the left hand side becomes pi. At x is equal to half, we get pi by 6. So from here we see that only at x is equal to 0, the left hand side is equal to pi by 2. So the answer is option C.